interested part of physics, which is as a building block for most of the things in electricity, and nothing more than what we call ohms. A scientist called Georg Simon Ohm. So we are going to look at his contribution in electricity. So, Ohm's Law. Ohm's Law is what we are going to consider today. Ohm, he was able to see the relationship between current and voltage. That's what ohms did. So let us state the law of this ohm. This Ohm's law states that provided other physical conditions such as temperature are kept constant, mark that one, are kept constant, the current passing through metallic conductor is directly proportional to the applied voltage. Ohm's law states that provided other physical conditions such as temperature are kept what? Constant, the current passing through metallic conductor is directly proportional to applied voltage. So you can now turn it over, but the most important thing you need to fish out in this definition is other physical conditions such as temperature, the current, and voltage is what? Directly proportional. So how can we do that? Mathematically, say voltage is directly proportional to current. So that means when you add voltage, the current also increase. When you increase voltage, the current also increase. So now, from this law, this sign of proportionality, we have V is equal to, if we want to remove sign of proportionality, we introduce equal, we add equal sign and introduce a constant. Is that okay? So if we want to remove proportionality sign, we add equal sign and introduce a constant. We add equal sign and we introduce what? A constant. So the constant now is R. We have introduced a constant, which is R. And this R here is called a resistance. So V is voltage or potential difference in volt. V, voltage or potential difference, that is PD in volt. V, I, current in ampere, then R is a constant, called resistance in ohms. Constant in ohms. So we can now, from the formula here, we can have make I the subject of formula, make R the subject of formula. If we make I the subject of formula, we have I is V over R. We make R is V over I. So these formulas are very important. We're using them all through. And in this Ohm's law, there are some materials that obey Ohms. And these materials that obey Ohm's law are called ohmic materials. So since we say provided other physical conditions such as temperature are kept constant, so it means that any materials or any conductor obey Ohm's law. Non-conductor or semiconductor does not. Because semiconductor, under condition, they change to conductors. When heat is applied, or when there is change in temperature, they become conductors. So that's why we say, provided other physical quantities are kept constant. But you see, semiconductors now, it shows that there is what change in temperature. Is that okay? So we have materials that does not obey Ohm's law are called ohmic materials. They are called what? Ohmic material. Non-ohmic materials, sorry. While those that obey Ohm's law are called ohmic materials. Example of ohmic materials, we have silver. As you know, we said that silver is the best conductor of electricity, followed by copper, followed by aluminum, and so on. Then we have example of non-ohmic materials. We have semiconductors, such as valve, track, transistors, thyristors, and so on. Is that okay? Good. So, can we now bring out a circuit which verify Ohm's law? A circuit that verifies Ohm's law. So as you can see now, this is how we connect a circuit that verifies Ohm's law. This is a cell or battery. This is ammeter. This is voltage, voltmeter rather. Then this is rheostat. So can you see? This is ammeter, this one. This is voltmeter, this one. Then this is rheostat, this one. Then a key with a key plug, this one. A cell, that is battery, this one. Then this is a Constantine wire, a wire that has a resistance. So this now gives us complete circuit which verifies Ohm's law. Because Ohm's law says provided other physical conditions such as temperature are kept constant, the current passing through metallic conductor. So all these ones are wires. All these ones are wires, conductors. Is that okay? So when you add voltage, current is also increasing. And you can see voltage is